Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over the buffer range and buffer capacity. So let's start with buffer range. So the first thing I want to note is that in a previous video we learned that the relative concentrations of an acid and conjugate base is important for buffer capacity. So we saw that if the relative amounts of your acid and conjugate base are equal to each other, then you're going to get the best buffer capacity or effectiveness for that buffer. The more the relative amounts or relative concentrations of your acid and conjugate base differ, the less effective that buffer is going to be. And we saw that in order to have still an effective buffer, the difference between the relative amounts of acid and conjugate base should be no more than a factor of 10. So we can take that fact that we learned and use the Henderson-Hasselbalch equation to find the pH range of any buffer solution. So we can figure out, well, for a particular acid and conjugate base, if we were to make a buffer out of that of those two, then we could see, okay, what pH range in which or over which this buffer would still be an effective buffer. So let's use the Henderson-Hasselbalch to find the lowest pH. So the lowest pH is when the conjugate base is 1/10 that of the acid, right? So we can use pH. Henderson-Hasselbalch is pH equals to the pKa. So pKa plus the log of the concentration of the base over the concentration of the acid, right? So since we know that that the base is 1/10 that of the acid, if we assume that the acid is 1, then that means the base is going to be 1/10 of that. So we could plug those numbers in, and we'll use the pKa of 5 like we've done in my other videos. So we'll say, okay, the pKa, that's going to be equal to 5.00 plus, and then the log of, okay, well, we can just use pK. We don't have to have 5. We can just do pKa. That'll be better, because then the pKa is just going to depend on what acid and conjugate base we're going to be using. So let's just use that as a general pKa. And then if we put that in as log, so this will be plus the log of, if the acid is going to be 1, right? So like say 1 molar, then we're going to say that's 1/10 of 1 molar, so 0.1 molar, right? So then the base is going to be 0.1, and then the acid is going to be 1, and so that's going to be 0.1. And so if we do 0.1, then that's going to be equal to the pKa. And if you take the negative log of 0.1, that's going to be minus 1. So then the pH here, the lowest pH you can get is going to be the pH is equal to the pKa minus 1. So whatever your pKa value for your acid that's involved in your buffer is going to be that pKa minus 1. That's the lowest pH that you can have an effective buffer. And then so if we do the highest pH, so that's when the base is 10 times the concentration of the acid. So it's flipped now. So if we use our Henderson-Hasselbalch equation again, so here the pH is going to be equal to pKa, and again that's going to be plus the log of the base over the acid. Okay, so let me kind of divide that. Okay, so then we do the same thing. So here pH is equal to pKa, and then plus the log of the base over the acid. So again, if the acid is 1, then the base is going to be 10 times that, so 10. So here we would have 10 over 1. So if we take the log of 10, that's going to be plus 1. So then that's going to be equal to the pKa plus 1. So if we kind of circle that, and then we circle this. So here, the highest pH that we can get for a certain buffer is going to be the pKa of the acid that's involved in making that buffer plus 1. And then the lowest pH is going to be the pKa minus 1. So the buffer range for any buffer is going to be the pKa value of that acid involved in making the buffer plus or minus 1. So that means as long as the pH of the buffer falls within that range, then it's going to be an effective buffer. If the pH of the buffer falls outside of that range, then it is no longer an effective buffer. Okay, so that brings us to buffer capacity. So what is buffer capacity? So the buffer capacity is going to be the amount of acid or base that we can add to the buffer without causing a large pH change. Okay, so again, we want to stay within that range. So staying within that range means that we can only add a certain amount of acid or base that's going to keep within that range. And so the couple of notes based on what we've said so far regarding buffer capacity is that the buffer capacity is going to increase when? It increases with increasing absolute concentrations of the buffer components. So what does that mean? So we saw before in an earlier video that if the absolute concentrations, the higher the concentration of our acid and base, that means it's going to be a more effective buffer. It's going to resist the change in pH more. We saw that in an earlier video where having a higher pH or having a higher concentration of your acids and your conjugate acid and base only had a very tiny change in the pH of the buffer when you added a strong base to it. Whereas if the concentrations were 10 times lower, then you threw in the same amount of base, you got a larger pH change. So higher concentrations of your acid and base, the absolute concentrations of your acid and base is going to make it a higher buffer capacity. So it increases the buffer capacity. The other thing we said is the other thing to note is that the overall buffer capacity increases as the relative concentrations of the buffer components become closer to each other. So that's talking about, remember, the relative concentrations. So the better the buffer, the closer the acid and conjugate base are to each other in relative amounts, then the more effective the buffer. So you want the best you can get is a 1-to-1. So if you can get equal amounts of your acid and conjugate base in your buffer, then that's going to be that's going to increase the buffer capacity. So there's two things you want to keep in mind that affects buffer capacity. It's the absolute amounts of your acid and conjugate base, and it's the relative amounts of your acid and base. So the relative amounts should be close to each other, like equal to each other. The more equal that they are, the better the base, the better the buffer capacity. And also the capacity increases again with the absolute concentration. So the higher the concentrations of your acid and base, the higher the buffer capacity. The more dilute your buffer is, the lower the buffer capacity. So I hope this helps explain and clarify buffer range and buffer capacity. If you enjoyed this video and you learned from this video, please smash that like button, like it right there, hit that button, And also, please subscribe to my channel. Help me out. Hit that notification bell so you can be notified by other awesome videos that I put out. Also, put a comment in the comment section. Let me know what you think. If you have any questions, if I made a mistake, I make mistakes. I'm human. So if I make a mistake, point it out to me. I'd love to hear from you. Thanks for joining me. Have a great day.